All right, here we are, the final exam practice. Since there are so many problems, I think there's 58, I may separate this video into 3 different sections. That way there would be easier to find a specific problem you're looking for. So we'll see how it goes. There's a lot of problems and we'll work it out. All right, number 1, he's asking me to find the distance between these 2 points. And point 1 he gives me at -2, comma 1, and the second point he defines as -5, comma -3. Well, the first thing I need to know is the distance formula. The distance is the square root of x sub 2 minus x sub 1 quantity squared plus the difference of the y values, y2 minus y1 quantity squared. I'm going to refer to this as x1, y1. I'll say this is x2, y2, and from here on it's just a matter of substituting in. And let me see if I can just darken this just a little bit so it shows up a little better. Alright, so it's the square root of x sub 2. X sub 2 is -5 minus x sub 1, so it's minus a minus, which becomes a positive. And that's squared plus the difference of the y values. It's a -3 minus 1. And I'm going to square that. Let's see. -5 plus 2 is a -3 combined. I'm going to square that. -1 combined with a -3 is a -4. And I'll square that. And what do we got here? -3 squared, well that's 9. -4 squared is 16. 9 plus 16 is 25. 25 is a perfect square. Square root of 25 is 5. Alright. Right off the top, when I looked at these answers, letter B was kind of suspect. These points were fairly close together, so I kind of, looked at B and said, I doubt it's going to be 25. Alright. Number 2, probably one of the easiest problems, finding the midpoint. Point 1 he just defines as 7, comma 1. And point 2 he defines as -16, comma -16. So the midpoint is the average of the x values. It's x1 plus x2 divided by 2. And y1 plus y2, all of that divided by 2. So what do we got here? I'll call this x1 and I'll call this x2. x1 is 7 plus a -16 averaged out. And my y values, some of my y values, my y1 is 1 added with a -16 and divide that by 2. Let's see, -16 combined with a positive 7 differences. Signs aren't alike, differences 9 and it's negative. So I know my x value, my midpoint is -9/2. And right now, I'm not even going any further. Right here. This is the only one that has -9/2. I mean, you can add these two together, get -15 divided by 2 and -15/2. We're all done. Letter B. Number 3, he's asking me to write the standard form of the equation of a circle with radius r and center hk. So we know this. Here's the general form of a circle. It's x minus h quantity squared plus y minus k quantity squared equal to the radius squared. So he tells me here that the radius is 3. So already I know that 3 squared, that's going to be 9. Well, there's only 2 answers that have a 9 for the radius squared. So already I know it's not A and it's not B. And that's kind of helpful because, you had 4 choices, now you're down to 2. Alright, so the point in question, the HK, I should have written this down. The HK is -1, comma 3. Alright, so this is my H and this is my K. So X minus my H value. X minus a -1. X minus a minus is a positive. X plus 1 quantity squared. And already, I was down to C and D. D is the only one that starts out with X plus 1, so here again, I'm all done here. there's ways. Y minus k. Y minus k. There's your k value. Y minus 3. Quantity squared equals to the radius squared. Radius was 3. 3 squared is 9. So here again, you kind of knew this going in. There's ways that you can make life easier for yourself, all right, using, I'm not sure common sense, but just utilizing all you've learned and studied throughout our 10 weeks together. So now he flips the script. He gives us an equation. He wants me to write this equation in standard form. All right? He wants me to tell him the h, the center of the circle. He wants me to tell him the radius. What we're going to do here is use completing the square. So first thing we do, we just write this x squared. This is number 4. X squared plus y squared plus 14x plus 12y plus 21 equal to 0. And my first job is this, is to put the terms that contain x side by side. Alright, so x squared plus 14x. I'm going to leave a space, and I'm going to write my y terms side by side. Y squared plus 12y, leave a space. Take that 21, that constant, and bring it onto the other side as a negative. Now, completing the square says to take half of this middle term here. All right, half of a positive 14. Half of that is 7. And then once you get half of that middle term here, square it. All right, 7 squared is 49. So I'm going to add 49. I've just completed the square. Now I want to add 49 on both sides here. If I add 49 to the right side, I got to balance it out by adding 49 to the left side. And once again, half of a positive 12 is 6. Now I'm going to square that. 6 squared is 36. I'm going to add 36 here and add 36 here. Now I've completed the square. Half of this 14 was 7, so what this guy looks like is x plus 7 quantity squared. By adding 49, I completed the square. I made this into a perfect square trinomial. Alright, if you take x plus 7 and you FOIL it out, that's what you get. Plus y, half of the middle term here was 6. The 6 comes right back at you. Alright, if I take y plus 6 and I square that, this is what I get. So already I know, alright, that the center, the equation of a circle in standard form is x minus something. So how do I express a positive 7? Well, x minus a minus 7 plus y, positive 6, I'll write as x minus a minus 6 quantity squared. And what do we got here? Let's see, 49 and 36, what's that? 5, it's 85 minus 21. He's so nice to us because he makes that a nice perfect square, 64. Alright, so this represents the radius squared. So if the radius squared, well, I don't even need to do that. I just, this is just what we've got going on. I want to leave this alone. I'm looking for something that matches up. Well, here again, my h value is minus 7. My k value is a minus 6. And my radius is the square root of 64. If r squared is 64, then r is the square root of that 8. So number 4, sure looking like letter B. Negative 7, negative 6, negative 7, negative 6. And the radius is the square root of 64, which is 8. Completing the square. It takes some time, but it works out if you go slow and do all the steps that you need to do. Now, here he's asking me which one is not a function. And we've determined whether something is a function or not by using the vertical line test. So, theoretically, I could graph each one of these and see which one doesn't pass the vertical line test. But if you realize, right, in studying circles, that this can be expressed as x minus 0 quantity squared plus y minus 0 quantity squared equal to 2 squared. What you got here is a circle. All right, a circle centers at 0, 0, and its radius is 2. Circles are not functions because they flunked the vertical line test. So that's the way I would have looked at this. Or you could have actually graphed this and found out that it's it's called a square root function. This is a linear function. This is the absolute value function. So obviously A, B, and C were functions. This guy here was a circle whose center was at 0, 0. Circles are not functions. All right. If you didn't realize that, you would have taken the time to graph each one of those and realize that A, B, and C all passed the vertical line test. I mean, I could show you the graph, but no. All right. If you recognize that, whenever you have an equation with x squared and y squared like this, you put a circle. In this case here, the center is 0, 0. Circles aren't functions. They flunked the vertical line test. All right. Number 6, determine whether the relation represents a function. If it is a function, state the domain and name. To be a function means that for every x value, there's a unique y value. The first thing I see is that no x value is repeated. All right, so I've got a function here. All right, so my domain is the set of all my x values. All right, so my domain is -1, 2, 4, and 8. Right there I see it. All right, my range is my set of y values, 8, 4, -5, -2. Yeah, we got it, letter A. That was an easy one. I like to think at this stage of the game they'll all be fairly easy. Number 7, solve the inequality. 10 less than or equal to 2x plus 2, which in turn is less than or equal to 12. Let's just kind of play a game here and see if we can cut to the chase. I've got less than or equal to's on both ends here. All right, so these are both going to be brackets. A bracket here and 2 brackets. Well, ain't got any bracket there at all. I've got 2 brackets here, 2 brackets there. This has 2 parentheses. All right, so by doing that, I just avoided making a careless error answering B or D. So my answer is either going to be letter A or letter C. So my objective is to get x by itself in the middle. So I'm going to start out by subtracting 2 in the middle and on both ends. 10 minus 2 is 8, less than or equal to 2x, which in turn is less than or equal to 10. And then divide everything through by 2. 8 divided by 2 is 4, less than or equal to x, which in turn is less than or equal to 5. So what have I got? An interval notation, bracket, positive 4, comma, on the other end you got a 5, bracket in a bracket, and we see that number 7 is letter C. All right. Number 8. Here we can play the same game here. Not game, it's just using your skills. You get a less than or equal to, which is a bracket. Here you got a strict inequality, less than, parenthesis. So I got a bracket and a parenthesis. Bracket, parenthesis, 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 no way. Parenthesis, parenthesis, no way. Here I got a parenthesis and a bracket, but I'm looking at this guy strongly because of the fact that the bracket shows up first, but I don't want to get too cute. Well, here again, let me just write this down. You can probably see that it's that's letter A. Minus 2 less than or equal to x, which in turn is less than 9. So I got a bracket at -2 left of that, and a parenthesis here. You can see now you got letter A. All right. Not much going on there. Number 9 coming up. Graph the inequality x less than 6. If I can spit it out. X less than -6. All right, so it's a strict inequality, which is a parenthesis. All right. And I've got a parenthesis at -6, and I'm going to my left. Okay, so you got a bracket here and a bracket there at -6. This is a strict inequality, so it's not A, it's not C. Now what's going on? These look alike, but if you look at these, the interval notation is messed up. All right, they're the same values, but The reason it's letter B and not D is that with negative infinity or even positive infinity, it's always associated with a parenthesis. Reason being, there is no number exactly equal to infinity. All right, so we're associated with negative infinity, which is out here. It's always a parenthesis, not a bracket. That's why it's letter B and not D. He's being cute, trying to mess you up, try to have you make a careless error, but you're smarter than that. Which one is not a function? Well, we just talked a minute ago that circles aren't functions because they flunked the vertical line test. Be nice if I could draw a vertical line, but you get the idea. This passes the vertical line test, that passes, and that passes. So which one is not a function? Number 10, it's letter C. All right. Another quickie. This one, you could actually put into your calculator and graph it. And what you would realize here is that you've got the top part of a circle. All right, this is not going to give you a complete circle. If you put this into your calculator and graph it, you're going to come up with the letter A for the correct answer. And I don't think there's any need for me to do it. You know how to put this into your calculator. You know what the square root function is, and that's what will happen. If I had the negative of this, all right, if I had the negative of this, then I would have gotten the bottom half of the circle here, all right, but I didn't have, all I had was a positive, all right. So if you graph this, put this in your calculator, you'll see it's letter A, the top half of a circle, whose radius is 4, and center at the origin. List the intercepts for the graph of the equation. All right, number 12. Y is equal to x plus 5. Here again, you could graph this, but there's no need to. The x-intercept is where the line cuts across the x-axis. So it's x, comma, 0. The y-intercept is the point 0, comma, y. So to find the x-intercept, I'm going to let my y value be 0. In place of y, I'm going to substitute 0 and solve for x. Take the 5, bring it on the other side as a negative. So I got my x-intercept as negative 5, 0. Alright, so I'm looking for, on number 12, I'm looking for something that says negative 5, 0 for my x-intercept. Well, it's not going to be letter A, negative 5, 0. I got a negative 5, 0, and don't have a negative 5, 0 here. So it's either going to be letter B or C, depending on my y-intercept. The y-intercept is 0, comma, y. So to solve it, here's my equation. I'm going to let my x value be 0. 0 plus 5 is 5. So my y-intercept is 0, comma, 5. If I go back to it, I see it right here, 0, comma, 5. Negative 5, 0, and 0, comma, 5. Number 12, letter B. Number 13, I'm not quite sure. Right, well, we really didn't handle these, but I'm going to do it anyways. Whether or not you see this on your exam, I don't think you will, because I didn't. This was, I believe, section 3, 4. All right, but I'm going to solve it anyways, because we're here. Quantity 2x minus 1 squared equal to 25. What I need to do is to negate the square. How do I negate a square? By doing the inverse operation, taking the square root. Now, when I take the square root of the right side, I have to consider the positive as well as the negative, because it's a second degree equation. I'm going to have two answers. Taking the square root of something squared just leaves me the thing under the radicand, thing under the radical, equal to plus or minus 5. So it tells me that 2x minus 1 is equal to 5, or 2x minus 1 is equal to negative 5. Adding 1 on both sides, 2x is equal to 6, x is equal to 3. And solving this by adding 1 on both sides, I'd have 2x, let's see, bringing that over, negative 5 plus 1 would be a negative 4. And dividing both sides by 2, x would be equal to a negative 2. So I got two answers, negative 2 and positive 3, letter A. Negative 2, positive 3 are my two solutions. You solve this square by doing the inverse, taking the square root. But what you need to remember is you take the square root of the right side, you have to consider the positive as well as the negative. And that's what gives you your two answers. All right, number 14. Absolute value problems. We've done a whole section on this. And once again, absolute value problems are going to have two solutions. So what do we got for 14? The absolute value of 5 minus 9x is equal to 8. So that translates that 5 minus 9x could have been 8, or 5 minus 9x could have been negative 8. But since it was enclosed in parentheses, we made it positive. All right, solving the first part, minus 9x, bringing the 5 over as a negative. 8 minus 5, that'd be 3. Dividing both sides by negative 9, x is equal to a negative 1/3. So what I'm going to do right now is check my answers and see which ones have negative 1/3. Well, there's only one of them has negative 1/3 as a solution. I'm done. I mean, if you want to solve this, go right ahead. Minus 9x, bring that over as a minus. That's a minus 13. Divide both sides by negative 9. X is equal, signs are the same, quotient is positive, but there you see it positive. But you knew, that was the only one that had the negative 1/3. Why, why go through that? Makes no sense. All right. The only way it would make sense is if you did something wrong, you just happened to stumble upon the wrong first answer. So maybe you want to take the time to do the other one, but I don't think so. All right, 15 is another one that kind of falls into the same category. And I know you won't see one like this, but I'm going to do it for you anyways because you paid your money, so it doesn't hurt. All right, so unlike the previous one where we did the inverse of squaring was to take the square root. Now I've already got a square root. So if the inverse of squaring is to take the square root, the inverse of taking the square root is to square. So I'm going to take this left side, if I can write 22x minus 11, and I'm going to square it. Now, here's the little trick. When you square the right side, you can't square each term individually. You have to take this as a binomial and square that. You cannot square each term individually, which makes more work for you. Squaring something under the radical gets rid of the thing. Gets rid of the radical. Now when I FOIL this out, I get x squared, 5x, and 5 more x is 10x. 5 squared is 25. Alright, so I FOILed that, but how many times have you FOILed? Now my job is to bring everything on to the same side of the equation. What I'm going to do here is I'm going to take this right side, bring it to the left, and left to the right. Makes I think a little bit easier to see what's going on. I'd rather my square term be on the left side. So I'm going to bring this over as a negative and bring this over as a positive. So I got x squared plus 10x minus 22x plus 25 plus 11. And now this right side is cleared out. It's 0. Combining like terms, x squared minus 12x plus 36 is equal to 0. And let's see what happens here. This is a trinomial. I'm thinking, I hope I don't have to solve this by the quadratic formula. So I'm going to take a look at this. X and x. This is a positive, which means the signs here are the same. This is negative. Yeah, they're the same. They're both negative. What times what is 36? 6. Let's see, a minus 6, another minus 6 gives me a minus 12. Alright, so I got either x minus 6 equals 0 or x minus 6 equals 0 again. It's only going to be one answer, and that answer is going to be, if I bring this onto the right side, x equals 6. This is what's called a double root solution. You got two answers here. They're both equal to 6. All right. It's a double root solution. So what do we got? Number 15, letter B. Here again, I didn't cover this, but I'm just showing you because you just never chance this is section 3, 4. You will not see something like this on the exam, but at least now you know how to do it. Alright, so, and if I didn't do 15, if I didn't do square roots, I certainly didn't do cube roots, but you get the idea here what's going to happen. Number 16, you get the cube root of 2x plus 5 is equal to negative 3. What undoes a cube root is to cube. Alright, what's going to negate the inverse of taking the cube root is to cube this left side. And then if you cube the left side, you got to cube the right side. Cubing undoes the cube root. So it's 2x plus 5 equal to negative 3 times itself 3 times is a negative 27. Subtracting 5 on both sides. Negative 27 minus 5, you get 2x equal to a minus 32, dividing both sides by 2. 2's cancel out, x is equal to a negative 16, and there you see it, the letter C. Alright. So if you were, even though you weren't presented with this, we didn't study it, what you could have done, as soon as I break my camera here, what you could have done with something like number 16 is, substitute in the values, put in 2 here. 2 plus 2 is 4, 4 plus 5 is 9. The cube root of 9 is not negative 3. You would have popped in negative 16. 2 times negative 16 is a negative 32 plus 5 is negative 27. Yeah, the cube root of a negative 27 is a negative 3. So that would have been even maybe the faster way of doing it, hoping that, we didn't have to check out those two fractions, which would have been a big deal because the 2 would have canceled it. What I'm trying to say is multiple ways of solving it. The more you know, the more strategies you have. I did it the long way, but let's see. What I'm probably going to do is stop at number 19 for this first video. Alright, the first thing I see here is that I got a third degree equation. Third degree equation means there's going to be 3 answers. Yes, 2 of them or all 3 of them could be the same number, but I got 3 answers. I'm looking at this and saying I'm suspect here. There's only 2. I'm suspect here, unless 2 of the answers were 8 or 2 of them were negative 7. The same thing here, but already I'm kind of suspect about these. I'm looking at A and D because they straight out have 3 answers. So I'm leaning that way. X cubed minus x squared minus 56. 56x, equal to 0. What I see is a common term of x. I can factor that out. X squared minus x minus 56. If the product of this times this equals 0, either this guy equals 0 or this trinomial equals 0. So one solution already is x equals 0. So as I look at this, I see A has a 0 and I see D has a 0. Okay, so now let me take this quadratic and factor it. Give myself a little space here. So x times x is x squared. I got a minus, so my minus product means my signs here are unlike. What are the factors of 56? 7 and 8 comes to mind. My middle term is negative, so I'm going to make the larger number the negative. And that would give me a minus 8 combined with a positive 7. Yeah, minus 1. So if the product of these two guys is 0, either x plus 7 equals 0, which implies x is negative 7. And already I see, yeah, there it is, negative 7. Solving this, if x minus 8 is equal to 0, then x is equal to positive 8. Negative 7, positive 8. Here we go, letter A. Alright. I'm looking at number 18 and I'm saying, well, it's a quadratic. Hopefully we can factor it. If not, we can't factor it, then we have no choice but to do the quadratic formula. But already I'm seeing 21. Factors of 21, 3 and 7, suspiciously 3 and 7 add up to 10. So I'm pretty confident we can factor this. X squared minus 10x plus 21 equal to 0. Draw my parenthesis. Here's my x and my x. This is a positive. It tells me my signs are the same. I look here. This is negative, so they're the same, and they're both negative. And the factors of 21 I'm going to use 3 and 7. Minus 7 combined with a minus 3, it's a minus 10. So either x minus 3 equals 0 or x minus 7 equals 0. This gives me x equal to 3 or x is equal to a positive 7. So number 18, we got letter C. All right, 7 and 3, 7 and 3. Now, number 19, I'm looking at the factors of 25. 1 and 25 and 5 and 5. Neither of those sets pairs adds up to 6. I need to do the quadratic formula. Now, I've got a video that shows you how to program your TI. You may or may not use that. If not, you got to manually do it. So it's the opposite of b plus or minus the square root of b squared minus 4ac divided by 2a, where my a value is 1, my b value is 6, and my c value is fairly large. It's 25. So, the opposite of b, the opposite of 6 is a minus 6, plus or minus the square root of b squared. If b is 6, I want to square 6 minus 4 times the product of a and c. A times c, 6 times 25, that's $1.50. Alright, all of this divided by twice a, twice 1 is 2. So moving down, and this is by number 19. Alright, so what do we got here? A negative 6 plus or minus the square root of 6 squared is 36 minus 600. Wow. Divided by, all this divided by 2. So a minus 6 plus or minus, what's 600 minus 36? 4. 6, 564, 10, yeah, alright, it's a negative 2. A negative 564. All of this divided by 2. Now, but the problem becomes now is dealing with this very large negative value here. Now, 564 is not a square, but the idea is, how do I take this and write it as a perfect square? Or, well, the best thing to do here is take 564. It could be divisible by 4. Let me just see. I'm going to divide this by several numbers that I know are perfect squares. Does 4 go into 564? 1. This would be, that's 140. 141. 6x plus 25. 36. 104 times. Letter C. Let me just try something here. 16 times 16. 96. 6. 161. 256. 4. 10, 504. I'm just thinking to myself here. 20, that's 600. That was 36, 564. Factors of 564 that are perfect squares. Let me see if 36 goes into this. Just trying to think of an easier way of doing this. No. Alright, I'm going to stop the video here. I need to find a faster way of doing this, and right now I'm not doing a great job. So I'm going to stop. I'll pick up with the second video with number 19. I'll start it from scratch. That's just a huge number, and finding something that is a factor of that is also a perfect square. 64 won't do it, will it? 64 into 564. That's 9, 36. No, that's not going to do it. Alright, we stop the video. I'm going to start the second video with number 19 because I got to find a faster way of doing that for you. Alright.